So 2a asks you to do something very similar as in question 1a. In this case, we've got again a 3 centimeter tall object. We've got an object that's placed at 10 centimeters distance. So this is going to be a U and an F of 5 centimeters this time of your lens. So again, as before, let's create our optical axis. On the optical axis, we'll place now 2, 4, 6, 8, 10. We'll place a slightly better version of my converging lens. That's the arrowheads, always making sure they're included, because that will show you that it's a lens and it's a converging lens. So now, having placed the lens, we have to 5 centimeters the focal length. So there's one focus point, there's the other 1, 2, 3, 4, 5. That's a distance to each side, equally placed. Now the object is placed at 10 centimeters. So 2, 4, 6, 8, 10 at this point, counting from the center of the lens along the optical axis. On there sits that upright 3 centimeter tall object. Now again, we'll construct the 3 principal rays. Let's start with the central one, going through the center of the lens, unchanged. The parallel one, parallel to the optical axis until it hits the lens, then it'll change and go through the focus point. Then we've got our focus beam that goes through the focal point, or best is to say it's a line connecting both the tip of the object and the focus point, and you just extend it into the appropriate direction till it hits the lens. And then if it hits the lens, it turns into a parallel one. Hit presto, now I've got more practice. I've got this actually to meet more or less in the same point here. So that is now going to be my constructed image. As you can see, the image is now being constructed, and you can see it's 3 units tall and it's also 10 units away from the object. This is not per chance. This is if you see the distance from the object to the lens is twice the focal length. So if you have this specific special distance, the image is exactly the same magnification and distance as it was before, just inverted.